Today we're talking about vector functions and space curves. So a vector function is a function whose domain is a set of real numbers and the range is a set of vectors. We are most interested in vector functions whose values are three-dimensional vectors. So that means that for every number in the domain, for every number t in the domain of R, there will be three functions, um, f of t, g of t, and h of t. They are components of our vector r, and then it can be written r of t, the vector r is f of t, g of t, h of t, or it can be expanded as f of t I plus g of t j plus h of t k. So we saw that before. So for example, if I have our vector function r of t is t cube ln 3 minus t square root of t, then the components are going to be f of t are t cube, then g of t is ln 3 minus t, and h of t is square root of t, is the square root of t. So that means that R consists of all the values for t for which this expression is defined. So we will have to think about square root of t. We know that for square root of t, t should be non-negative. And then also we have ln 3 minus t. So we have to think about 3 minus t being greater than 0. So from here we get that t must be less than 3. And that means that our domain is the interval from 0 to 3, bracket, parenthesis. Now, what's a limit? A limit or the limit of a vector function is defined by taking the limits of its component functions. In other words, in other words, here is my bigger definition. Let me increase this one a little bit. So in other words, if r of t is f, g, and h of t, then the limit is going to be limit f of t, limit g of t, limit h of t when t approaches a. And same as before, a can be 0, it can be infinity, so whatever. Let's take a look at another example. So my example number 2, let me bring this over here. Okay, example number 2 is going to be to find limit r of t, where r is 1 plus t cube I plus t e to the negative tj plus sine t over t k, and the limit when t approaches 0. Well, that means that we're looking for... That means we're looking solution, limit r of t as t approaches 0. So we're looking for limits of all the components. So limit 1 plus t cube I when t approaches 0. And I'm going to put this into brackets. I is a vector, r is a vector, plus limit brackets te to the negative t j as t approaches 0 plus limit sine t over t k. You already know from calculus that when t approaches 0, you're going to get over here, the limit is going to be 1, right? T approaches 0, so 1, so that's going to be I. When t approaches 0, e to the negative t decreases faster than t grows, so that limit is 0. And then sine t over t, when t approaches 0, is going to be equal 1 as well. So at the end, we're going to get just I plus k. So the limit is going to be I plus k. Since we're talking about limits, the next thing that comes with limits is a notation of continuity, right? So then we would say that a vector function r is continuous at point A if limit r of t when t approaches a is equal r of a. Okay, same thing as before, same thing as when we discussed continuity of regular functions.